Hello, my amazing students. This is Mrs. A, and we are on 9.1, which is radical expressions and functions. So, the first thing we're going to do is find all of the square roots of 81. Now remember, the rule is that if you do not see a radical sign, then you are taking the square roots, and you must remember that there are two roots to 81, 9 and negative 9, both square to give you 81. 9 times 9 is 81. Negative 9 times negative 9, the negative sign squares out, so that equals 81 also. So when you do not have a radical sign over it, then you need to consider there are two roots. When you see the radical sign in a problem, you see it sitting there on a page, on a computer screen, in a book, then you are to assume that they want the principal square root, which is the positive square root. Okay, so the principal square root is the one that we assume goes with the radical sign. Okay, so this is the square root of 16, and although 16 does have two square roots, plus and minus 4, we're only going to use the positive 4 because this notation means the principal square root. This one has a negative sign outside of the radical sign, and so we'll do what's inside the radical first and get 9, and this is going to be negative 1 times, we'll get 3, and this will be negative 1 times 3, or negative 3. Now, we're going to see in just a little bit that whenever we have a radical and a whole number underneath, a fraction underneath it, we can break that up into two radicals. So we are able to say this is the same thing as square root of 36 over square root of 49, and square root of 36 is 6, and square root of 49 is 7. So if you square 6/7, you will get 36 over 49. This one, when you square 10, you get 100. When you square 3, you get a 9. And so 10 thirds squared gives you 100 over 9. And then the negative is a negative 1 times, so we're going to put a negative out there. We have another square root on the top here. Now we have a negative inside the radicand. And the rule is that when we have an even index or root, in other words, there in here, this square root, there is an understood 2. It is the second root. But we never write the 2 because square roots we use so much that we just, if we don't see any other kind of root, like this one has a cubic root, if we don't see any root, we know it's a square root. And there is no number that when multiplied by itself will give you negative 64. No real number on the real number line will do that for you. So we will write, and remember this is just my little notation that I accept, okay, narn, not a real number. Okay, so if you're in anyone else's class, you have to write out not a real number, but in my class, you can write narn because I know what that means. Okay, not a real number. So then we move on to higher roots. So now we're talking about higher roots, and the first one we're going to talk about is the cubic root of 27. All right, so I know that 3 cubed is 27. So the cubic root of 27 is 3 because 3 cubed gives me 27. Okay, the cubic root of 64. So I'm looking for a number that when you multiply it by itself 3 times or cube it, it will give me 64. And I know that 4 times 4 times 4 gives me 64. Therefore, I know that the answer is 4. Now we have a negative under the radicand. This time it's legal because I have an odd index and there is a real number that I can multiply by itself 3 times to get -1. And that is -1 times -1 times -1. All right, remember -1 times -1 gives me a +1. But then when I multiply by a third -1, I get a -1 again. So the cubic root of -1 is -1. Okay, so a negative underneath the radicand is not a problem if we have a cubic. So here's a cubed root, and -27 is underneath the radical. There is a real number that will cube. Something cubed will give me -27, and that is a -3. -3 times -3 times -3 gives me -27, so the answer is -3. The fourth root of 81. Now, fourth root is an even root, but there's no negative under there. There's a negative outside, which does not cause a problem. That's just -1 times whatever the fourth root of 81 is. And I know that there is a number that when you raise it to the 4th power, you get 81, and that number is 3. 3 times 3 is 9, and we know that 9 squared is 81. So the answer here, this part is 3, but then the -1 in the front is going to make it -3. And we will be back with some more. So we have the fourth root of -81. Now, since the fourth root is an even root, then I won't have that odd negative sign to make it negative again. Therefore, there is no real number that will raise to the 4th power to give me a negative anything. Therefore, I will say not a real number. But here, I've got a cubic root, and a cubed root is odd, and that means I'm going to have, every 2 negatives makes a positive, so I'm going to have that leftover negative to make the answer a negative. So I'm looking for what cubed would give me a -125, and the answer is a -5. Therefore, the answer here is a -5. The 6th root of 64. Well, I'm looking for something that is raised to the 6th power to give me 64, and that is 2. 2 to the 5th power is 32. 2 to the 6th power is 64. So the answer is 2. Here we have a square root of a -9 squared. Now what's going to happen to the -9 when I square it? It's going to become a +9, okay? And then, a positive 81, positive 81. And when I take the square root of that, it does exist, right, in the real number system, which is going to be a +9. So anytime I have the square root of any number squared, that negative is going to square out, which is going to make this exist, and I'm going to get 9 because the square root and the square undo each other. I get the square root of positive 81, which is 9. All right, so here we are talking about what happens when we don't know what the number is. Just like this -9 did not keep its negative sign because I squared it, and it came out +9. When we put a variable in, such as square root of r squared, we're still squaring whatever was there. So if r was positive, then of course we're going to get out the square root and the square undo each other, and we'll get out a positive r. If r was originally negative, then we have a little problem, because if it was negative, say it was a -3, we square it, it becomes a +9. The square root of that is a +3. So to take care of this with a variable, we will always say the answer is the absolute value of r. Anytime we have an even power with the same root, we will pull it out as r and say it must be a positive r. So we're going to say absolute value of r. Okay, now this one, we've got a cubic root of -2 cubed, but a cube does not change the sign of whatever you started with. So -2 cubed is -8, and the cubic root of -8 is -2. So the rule is we do not change the sign of the number when we have an odd root and power. We leave the sign alone. But when we have an even root or power, we put the absolute value sign on it if it's variable. If it's not a variable, we just make it positive. So here we have the 7th root of p to the 7th. So we have an odd root and power. So we're going to say p keeps whatever sign it started out as. Here we have a 4th root and a 4th power. So we don't know what z was originally, but we know that we need a positive answer out. So we put the whole thing in absolute value signs, z minus 6, the whole thing in the absolute value, and then we'll know we're okay. So now we have the 5th root of the 5th power here. So we've got 5th root of 7m plus 4, all raised to the 5th power. Since 5 is odd, it will not change whatever the original sign was, so the original sign will remain intact. This one, however, is fourths and a 4th power, so the 4th power will change whatever sign was already there, whether it's already positive or already negative. So we want the exact same thing out. So we're going to say 3y minus 4, but any negative sign would have been taken out with that 4. So we just make it all positive with an absolute value sign. Now we're going to begin evaluating square root functions. All right, so this is when we plug a value in. So they tell us that f of x is the square root of x, and g of x is equal to the square root of 2a minus 7. So then we have 4 values that we need to put in. The f function is the square root of x. So I'm going to slide the 49 into the square root of x. And I get the square root of 49, which is 7. Remember, they always mean the principal root when you see the radical sign already put there for you. Then f of -4 means that I'm going to put a -4 underneath the square root sign. The square root is an even root. The square root of a negative is going to be not a real number. Not a real number. And then we look at the g function now, because they're naming which function we're supposed to plug it into. G of 5. Well, if I plug in a 5 right here for the a, then I'm going to get 2 times 5, which is 10. Take away 7, which is 3, and I will wind up with the square root of 3. And then g of 3, I'm going to use the g function again. I'm going to plug in a 3, and I'm going to get 2 times 3 is 6. Take away 7 is -1. I get a negative underneath a square root function, so g of 3 is not a real number. Now we're talking about domains. To be able to find the domain of a function. Now, this is a square root function. Square root functions may not have a negative underneath the radical. They are not real numbers if there's a negative underneath there. So in order to find the domain, we set this number underneath here is called the radicand, remember? So we set the radicand greater than or equal to 0. So x is greater than or equal to 0, and that is my domain. That is my restriction on x. So now this, remember to put it into proper set notation, all I have to do is put a little bar in front and put x such that, and to put it into interval notation, since the interval starts at 0 and x is going to the right of 0, then I will say, it can be a bracket, excuse me. We'll put a bracket 0, comma, infinity. Parenthesis. Remember, I always use a parenthesis by the infinity sign. So that is the domain, both in set notation and interval notation. This one is a little trickier, but I'm still going to work it the same way. It is a square root, which is an even root, which means I can't have a negative underneath the radical. So I'm going to set 2a minus 7 greater than or equal to 0. When I do that, I will add a 7 to both sides. So add a 7, and I get 2a greater than or equal to 7. Then I can divide by 2, but since it's not a negative 2, I don't have to flip the sign. And I will wind up with a is greater than or equal to 7/2. Okay, so to put it in set notation, I will just put my little bar and my a in the front of that. Okay, so we'll erase this part right here and just put little bar, a in the front, make it set notation right there. And then interval notation, the interval starts at 7/2. It could be equal to 7/2, but then it goes to infinity and paren. So now we are working with our function notation and doing a little bit of substitution in, but realize these are cubic roots. Both of them are cubic roots instead of square roots. So we don't have that negative problem with cubic roots. So I'm going to take f of 27 means that I'm going to take the f function. I'm going to substitute the 27 up into where the x is. So my radicand is 27 and the cubic root of 27 is 3. When I plug in a negative 10, I'm going to use the f function again, as they noted. I'm going to go up to the f function. The cubic root of negative 10 is real because cube is odd. An odd root of a negative exists. It's on the number line, but it is irrational. If they had said the cubed root of a negative 8, we would have been fine. We would have said it's negative 2. We know right where it is. But the cubed root of negative 10, although it is real, is irrational. So we will leave it sitting underneath. That would be considered a simplified form of that one. All right, so here they define another, this was the h of that same function they had, but they didn't have any h problems on the other one. So I ran out of board space. I put the h over here. So we have two h functions. We're trying to evaluate h of 1. Means I substitute a 1 in here for my t. So I wind up with 1 minus 9, and that becomes a cubic root of negative 8. And the cubic root of negative 8 is negative 2. Because the cube is odd, I don't have a problem with that negative sign. There is a real number that will cube to give me negative 8. And when I plug in a 13, I'm going to get 13 minus 9 is 4. So I will get as an intermediate here, well, it's going to be my final, right? Because it's not a square root, it's a cubic root. And 4 is not a perfect cube. So that would be my final answer. I wouldn't do anything else to it. So now we're starting to graph these functions, okay? And it's very important to understand the graph of the function, or you won't understand the domain and why it does and does not exist in certain places. So here, we're just going to think about the square root a little bit. Let's do our x and our square root of x here, which is our y. Square root of x is our y. We'll say y equals, all right? So on this one, it is, I didn't write it all here, but this is f of x equals square root of x. I got sloppy. Okay, so this, your y is the square root of x, but it's often just easiest to put your square root of x there because it is your y value. If I plug in a 0, then I get the square root of 0, which is 0. If I plug in a 1, then I get the square root of 1, which is 1. If I plug in a 2, I get a weird number. So I'm going to go on to plug in a 4. And if I plug in a 4, the square root of 4 is 2. Okay, so I've got 0, 0, 1, 1, and 4, 2. So maybe over here, okay? And so I know it's going like this. If I want to continue, I would plug in a negative 1. And negative 1 is going to make a negative underneath the radicand, underneath the radical. And that's going to be not a real number. Not a real number. If I plug in a negative 2, it's not a real number. So all the way over here, it is not a real number. Therefore, my graph of my square root just goes off in one direction. And there is your graph. So now we're going to graph another square root. And this one has been translated. And the question is, where has it been translated or moved? Now, this is the rule I try to get everybody to memorize. If something happens outside of the function, it's going to affect the function up or down, okay? In other words, if I had a plus 3 on this function, it's going to shift the whole function up 3 steps. But if I have something going on inside my function, this is a square root function. If I have something going on inside the function, it will move that function to the left or to the right. Now, we know that this is a square root, and we know that whatever's inside it cannot be negative. So if you are setting x plus 1 greater than or equal to 0, you will see that when I take away 1 and take away 1 from both sides of that inequality, I will get x is greater than or equal to negative 1. So this actually moves the function one step to the left. There's a positive sign there, but it moves the function to the left one because notice, if I plugged in a negative 1 right here, I would get the square root of 0. And so whatever makes this go to 0 is where your function, your square root function, would start. So we're going to plug in the negative 1. And when we plug in a negative 1, so here's our little grid here. We've got our x and our y, or our g of x here. And we plug in a negative 1, and it works. We get negative 1 plus 1 is 0, and square root of 0 is 0. So negative 1, 0 is a point on my graph. If I plug in a negative 2, however, if I plug in a negative 2, then I go into the negative, don't I? I get negative 2 plus 1 is negative 1. An even root of a negative 1 is not a real number, so nothing is going to happen over here to the left. But if I plug in a 0, which is to the right of negative 1, then 0 plus 1 is 1. And I wind up with the square root of 1, which is 1. Okay, now let's think about what would be a friendly number. We knew that 4 was friendly. What about 3? If we plug a 3 in here, 3 plus 1 is 4. Square root of 4 is 2. So 3, 2 is a point. So we got 0, negative 1, 0, 0, 1, and 1, 2, 3, 2. So our square root graph should look exactly like the other one, except that it has been shifted one step to the left. Now we're working with cubic roots. We're going to graph the cubic root function. Now this is the parent cubic root function. Just like the square root of x was the parent square root function. The most basic cubic function we can get is cubic root of x. So once we learn how this acts, then we'll know how all cubic roots act. Okay, so children act like their parents, don't they? Sometimes that's unfortunate. But, so we're going to make a little grid here. Now remember that cubic roots do not have the same problem with signs that square roots do and even roots do. So if I plug in a 0, I get out a 0. Okay, cubic root of 0 is 0. So 0, 0. If I plug in a 1, the cubic root of 1 is 1. So I get 1, 1. If I plug in a 2, it's not going to be a pretty number. But if I plug in an 8, let's jump all the way to 8. The cubic root of 8 is 2. So I have to go all the way out here. And we'll just say it's right there. Okay, so we've got this function going on here. And then I have to think about the negative. So if I plug in a negative 1, then negative 1 times negative 1 times negative 1 does give me negative 1, and I'll get a negative 1 out. So negative 1, negative 1. And mirroring this one would be negative 8, negative 2. So if I plug in a negative 8, I get out a negative 2. And negative 8 is way over here, but we're just going to cheat a little bit and make it right there. So this graph is a cubic function, a cubic root, a cubic root. Your parent cubic root. All right, so now this is the last thing we have to do in 9.1. And when we look at it, based on what I said before, what do you think is going to happen? How are we going to translate the parent function here? So the parent function, remember, looks like this. This is my parent function. It's got a squiggle in the middle. All right, so this function is going to look just like it. Is it going to be moved up, down, left, or right? Well, the minus 2 is inside the function, so it should move it left or right, not up or down. And what would make that go to 0? X minus 2 equals 0. Add 2 to both sides, and I get x is 2. So let's plug in our points. 2, and when I plug in a 2, I get out the cubic root of 0. So 1, 2, and there's my point. All right. So then if I go 1 point to the right of 2, I put in 3. 3 minus 2 is 1. The cubic root of 1 is 1. So 3, 1 would be a point. Okay. And then I'm going to have to put in, if I wanted an 8 under there, I'd have to put a 10 in for x. So 10 minus 2 is 8, and the square root of 8 is 2. So way over here somewhere would be 10, 2. All right, so we know that the sweep is going to go up just like this. So let's go one step to the left of the 2. Let's go to 1. Okay, and if we plug in a 1, then we get a 1 minus a 2, which is a negative 1. And the cubic root of negative 1 is negative 1. So I get a negative 1, 1 negative 1, and 1 negative 1 would be maybe right about there. Okay, and then I'm going to plug in a number to give me an 8, and I'm going to plug in a negative 6. Because negative 6 minus 2 would give me a negative 8. I'm going to put it up here because I ran out of room. Negative 6 minus 2 is going to give me a negative 8 underneath the radical. Cubic root of -8 is -2. So another point is -6, -2, 1, 2, 3, 4, 5, 6, -2, and there is my cubic. Now, it looks real long over here. That's because I shifted it, right? So it's still the same shape as this function. That was the parent function, but it has been shifted 2 steps to the right. So I want you to notice this. We had a -2, but it shifted it to the right. So it really shifts it opposite of what you think naturally it would be, because what you're doing is say, what number will make this go to 0? That is the end of 9.1, and this is Mrs. A, and may God bless your day.